You may have seen this integral as the viral Wi-Fi password that has gone around a couple of times. On the surface it looks quite complicated, however it's not that bad. First notice the left-hand expression, x cubed and cos x over 2. Both of these are odd functions, but we could still do this even if only one of them was an odd function. From minus a to a, the integral of an odd function f of x is equal to 0. Similarly, from minus a to a, the integral of an even function, say g of x, is equal to 2 lots of the integral between 0 and a of that same function. We'll use both of these properties when solving this integral. X cubed and cos x over 2, from minus 2 to 2, their integral will be 0, so we can cancel that part out of our integral, and we're left with a half root 4 minus x squared. However, this is a circle, and a circle is an even function, so we can multiply everything by 2, change the limits, and we're left with the integral of root 4 minus x squared. Now, when you have a partial circle, from 0 to r, of r squared minus x squared all rooted, the integral of that is pi r squared over 4. In this case, r is 2, so our answer is pi. Let's move on to a really nice and simple technique, adding 0. If we have an integral like this, x squared plus 1 minus 1 will let us solve the integral much easier. Here we can split the integral up. We have x squared plus 1 over x squared plus 1 minus 1 over x squared plus 1. The left-hand expression is 1, and the integral of 1 is x. The right-hand expression is arctan. And that's the standard integral you should remember for integration B's. This is our answer. Next, a really interesting type of question that can come up is an infinite series. In this case, since it's from 0 to 1, it will converge, and this geometric series we can evaluate as from 0 to infinity x to the 2n. Using the formula a over 1 minus r, we can evaluate this as 1 over 1 minus x squared. So now we have the integral of 1 over root 1 minus x squared. You can do this with hyperbolic sub or regular trig sub. I'd rather do it regular trig sub of x equals sine theta. You end up getting pi over 2 as your answer. Now, a really nice and useful trick is the King's rule. To show it best, I'll use this example. Cos x plus sine x in the denominator, and cos x in the numerator. We will do u equals a plus b minus x. In this case, u is pi over 2 plus 0 minus x. Du over dx is minus 1, and then dx is minus du. This is good because the limits end up flipping, and you can use that minus in the du to flip it back. What we have is cos of pi over 2 minus u over cos pi over 2 minus u plus sine pi over 2 minus u multiplied by minus du. We can flip the limits, with a minus. And now, use the trig identities. Cos of pi over 2 minus x is equal to sine x, and sine of pi over 2 minus x is equal to cos x. This means we really just have sine of u over sine of u plus cos of u with respect to du. However, this is equal to our original integral, and so if we add these together, we have 2i equals, from 0 to pi over 2, of cos x plus sine x over cos x plus sine x. Variables don't matter, because fundamentally these are the same integrals. You can put whatever variable you want, they'll still be equal. And this is the integral of 1 from 0 to pi over 2, which is u from 0 to pi over 2, which is pi over 2. Now, 2i is equal to pi over 2, and so our final answer is I equals pi over 4.